Today I'm going to show you how to expose a Kubernetes service using AWS Load Balancer Controller. The previous and deprecated way was to create a service of type load balancer, and behind this AWS will create a unique load balancer for you for each service that you want to expose. This can be very expensive once you have multiple services to expose and difficult to handle, and also you will not have advanced HTTP features, and there is no host-based routing or path-based routing. With the new way, you can use the same ALB for multiple services. Okay, to follow easily this lab, you will have to clone this repository, and you can also follow all the instructions in my Medium article. I will put the links on the description. So we clone the repo and we go to AWS Terraform, the Terraform code here. We will deploy the network first, so the VPC with the private subnets and the public subnets, and the Kubernetes cluster using EKS module, and later we'll deploy the controller using the official Helm chart, and finally an application that we will expose, and we will test the controller. First of all, you need to create these S3 buckets to save your Terraform states. I already created mine. You need to create one and update all the codes to use your bucket. And just after, we'll start with the networking. So if we check the network code here, we have our VPC, and we'll create two public subnets and a route table to route the traffic to the internet gateway, some private subnets. Why we need to create two subnets? Because we'll have a regional cluster, and for regional clusters you need at least to have two subnets. Our cluster will be a private cluster, but we still need to create public subnets to reach internet, and also so the network from internet can reach the cluster. And the most important thing is that we should have these tags: the internal ALB set to 1 for private subnets, and ALB here set to 1 for the public subnets. This will be used by the controller later to be able to expose the service. Okay, so we have about 13 resources to create. The creation of the network can take some time, about I think 5 to 10 minutes. I will be back later after the creation. Meanwhile, I can show you need to have all the necessary accesses for the creation, obviously. We can follow here the creation of the VPC. I can see my VPC is already here. I created everything in Europe with 3, but you can change the region if you want. Great. Okay, the VPC was created. Now we are creating the NAT gateway. This can take some time. VPC was created. In the outputs here we have the private subnets, the public subnets, and the VPC ID. Of outputs that we will need later for the Kubernetes cluster. We'll have we need the VPC ID and the private subnets. So here we'll create the Kubernetes cluster. For the cluster, you can name it whatever you want. I'm using the recent version here. I use spot nodes, so it's cheaper, and you cannot go smaller than T3 small. So this is the smallest instance you can have. The minimum size you can keep it to 1, the max to 3. And you need to enable the OpenID for the Load Balancer controller. The cluster is private, but we still need to access it. So you need to enable the cluster endpoint public access, and we will enable EP filtering. So you need to put here your EP address. I am going to change this with my EP address. The Kubernetes series here. I'm using an alias, so you can just type Terraform. The creation of the EKS cluster will take about 15 minutes. Okay, so you can see that we have a lot of resources to create, the policies and the node pool, everything is handled by the module. Cluster is finally created. It took me about 10 minutes. Yes, okay. Now that we have the cluster, let's check it out. I need to go to EKS. Here is the main cluster. You need to check for the accesses here in networking that you have public and private access, and you whitelisted your EP address. Now that we have the cluster, we need to deploy the demo app. Before deploying the demo app, we'll just access the cluster and check out what we have in the kube system. Okay, this is the networking part, so we created the cluster. So to get the cluster, in my case, I created the cluster on Europe with 3 region. And I will save the kube config on a local file here. And we will just export that kube config. So now if I run kubectl git pods, I should have nothing on the default space. We can also check the resources that we have on the kube system namespace. Now we will deploy the AWS Load Balancer. So to do so, we will use the official Helm chart here. So as you know, you have two options to deploy the Helm chart. Either you can use directly Helm install with the chart name, but you can also do it using Terraform. From our data here, we get everything that we need from the cluster, the certificates, and the link, etc. After, we'll deploy the controller, and we also will deploy the IAM rule for the service account. So the service account of the controller will be AWS Load Balancer Controller. You can change it with the variable service account name. I will keep this one. So we'll apply first only these two resources. Apply first these two resources. First we do a Terraform init to get our module, and then we will apply the controller This will create the controller deployments and also the IAM policy that is linked to the controller. Great. Now we can check the status of the creation. With the Helm list that in Kube system we can get our Helm charts. So we can see here that the chart was deployed. And we can also get all the pods that were deployed. So here we can see that the chart deployed 2 pods of the Load Balancer Controller, a service, and the pods are controlled by this deployment. Everything is running. This is perfect. Now we can finally deploy our application and expose it. To deploy our application, it's a small deployment. So we'll deploy an EKS server. You can update the image and choose another service if you want. We expose the 8080 ports, and in front of this deployment we will create a Kubernetes service. The most important thing is that the type of the service should be node port. This is required for the ALB. And the most important part here is the ingress. It is necessary to have these 2 annotations. So here we specify that this service will be internet facing, and we specify here the class name that will be ALB. So for this, AWS will create an application load balancer for us. We specify the rule here. It will be an HTTP server, and the port and the service behind this rule. Great. Let's create all of this. I already did a Terraform apply. I targeted only these 3 resources, but even without the target, we'll have the same output. Everything was created on the default namespace, So if I run kubectl get all, I will see my eco app pods. Both of them are running, and here we have our eco service, a node port type with the correct port, and we can also check the ingress objects. So AWS created this application load balancer for us. We can check it directly in the console. So if I go to load balancers, we can see here that the load balancer is still on provisioning status. We have to wait a little bit for it to be ready. You can see here that the DNS name should be the same that we have with the kubectl output. So if I do curl http, let's see if it's ready. So it's not yet ready. Okay, the load balancer is ready now, so we can test. If we curl now the address, the DNS name, we should have an answer. And you can also do the test directly by accessing the web server. So congratulations, you have now exposed your Kubernetes service. For watching, don't forget to clean all the resources that we create, the Kubernetes resources, the cluster, and then the network resources, and also finally the AWS S3 bucket.